Today, I'm going to be ranking every type of integration technique that I could find on the internet using two criteria: how satisfying it is to use and how useful the technique is. So, first up, we've got integral of e to the 2x sine x dx. Can you guess what you use this one for? This is for integration by imagination. This is going in S tier because it's the technique that I personally love, okay? My friend told me this technique and it's absolutely amazing. If you don't know the technique, as a little bonus, I will be explaining this technique to you. This one is integration by imagination. This is the only technique that I'm going to be explaining in this video. If you want to see a full explanation of all the techniques, then make sure you leave a like below, because if we hit 2,000 likes, then I'm going to be explaining all of the techniques. So this one, integration by imagination, what you do is you say, okay, we want a sine of x, right? Sine of x is the imaginary part of e to the ix, because e to the ix, as we know, is cosine x plus I sine x, right? So if we say that we're only worrying about the imaginary part of the integral, then we can say that the integral is e to the 2x e to the ix. You see that? And now we've got something that we can simplify. And once we simplify it down, we get imaginary part of e to the 2 plus ix, look at my amazing handwriting, dx. And then we can integrate now at this point. So we just want the imaginary part of 1 over 2 plus e to the 2 plus I times x. And then once we've done all that, we can just expand out the e to the 2 plus ix back into back into the cosine I sine form, multiply it out and expand it, and then we can just get the imaginary part. I'm not going to do it all right here, right now, because the explanation video is coming later. But yeah, that is how you do integration by imagination, and it's absolutely amazing. It's satisfying. It's kind of useful. To be honest, because it's not very useful, I'm going to have to put it in A tier, because you very rarely have to actually use this, but when you do, it is satisfying. Next, we have the logarithm form. This is just logarithm of f of x. Useful, satisfying? No, but it's useful. Next, we've got, the sigma male. This is how you integrate if you're a sigma male, okay? Don't worry about the squirrely S symbol or whatever the hell. Just do a trapezium. You get roughly the right answer. Next, we've got this one here is constructive Feynman technique, and I don't think it's fair to use this one without having the Feynman technique first. So Feynman technique is where you use the derivative, the partial derivative with respect to an intermediate variable, and then you can find the derivative, and then using the derivative, you can prove the integral sort of backwards. It's a very fun technique. There's a million explanations of how this works on the internet, so it's very, very overdone, but it's very useful, kind of. Yeah, it's useful. It's useful and it's quite satisfying. So it's got to go in S tier. So this is the constructive Feynman technique. Very satisfying because you use differential twice instead of just once. So this is using the double integral, you could say. Sorry, the double differential, and then you do the same thing only twice. So it's amazing. Can get a little bit messy though. So I guess it's low S tier, right? It's low S tier. Next, we've got the Laplace transform. Very useful, very commonly used. Kind of satisfying as well, so I've got to put it in A tier. Next, we've got U substitution. Quite satisfying. I mean, if you can use a U substitution, you use a U substitution because it's so satisfying. Unless I'm going to have to drop it down a tier, because there are U substitutions, like, for example, this one. Where is it? Called the Euler substitution. Just Euler, it's such an oily boy. Oh, well, Euler substitution's not here. I think I didn't count it as a integration technique because it was just, oh no, it's here. Never mind. It's here. Euler substitution is complete trash. So for that reason, it's dropped down a tier. Next, we've got this King's rule here. Very useful, kind of satisfying, so I've got to put in A tier. Next, we've got integration by utter madness. Not satisfying, because it's very difficult to use, and because of that, it's not useful either. So complete trash. Other than its name gives it some points, but it's still in complete trash. Like, don't actually use that, okay? Next, we've got f of x is odd, so you use this. This cancels out to 0, so anything that cancels out to 0 is kind of satisfying. However, you've got to prove that f of x is odd in the first place, so not incredibly useful, not incredibly satisfying either. B tier, it's got some uses to it. Next, we've got this one here, which, this one is adding and subtracting terms. So you can add terms to the numerator and then subtract the same terms. For example, for this one, you would add 2x plus 1 to the numerator, and then you would subtract 2x plus 1 from the numerator, adding essentially a 1 term, so integral of 1 minus, and then it would be minus 2x plus 1 all over this denominator, x squared plus 2x +2. Not very satisfying, but it is useful, so we're going to put it in B tier. Everybody kind of knows that one. It's quite a common integration trick that they use whenever they think of integration tricks. Add something and then subtract that same thing. Next, we've got trig identity, C tier. I mean, come on, trig identity. Unless you've got sine squared or cosine squared, it's not very useful, and it's not very satisfying either. Next, we've got this one. I've honestly never used a parametric integration formula for something that's Cartesian. So if you've got a Cartesian formula, a Cartesian integral, just use Cartesian form. Otherwise, there's no real reason to switch it over to parametric. So yeah, if you're using parametric formulas, then yeah, definitely use the parametric form of integration. But otherwise, don't use it. It's complete trash. Next, we've got partial fractions. If you can use anything else, then don't use partial fractions. But if you have to use partial fractions, it is useful. Next, we've got a beta function, which uses the gamma function. The gamma function is quite satisfying, but the beta function requires a little bit more work. It's a little bit yet less useful because you barely ever have to use it. So C tier. Next, we've got the, this is the standard power rule that you learn when you learn integration. Very useful, not very satisfying, B tier. Next, we've got the reduction formula. Now, a lot of people use this, but in my opinion, if there's an alternative, like using de Moivre's theorem, I believe, or like something else, like even it's better than utter madness. So it's got to go in C tier. But if you can use something else, then use that other thing. But otherwise, yeah, you can use the reduction formula. Next, you've got integral of f of x over g of x, where f of x, the numerator, has a higher order. Then you just do algebraic long division, or you can use the tabular method for that. Using the tabular method, let's say, it's going to go in B tier because it's useful. Oh, look, we've made a little shape there. It's useful for certain applications. But if you can use another thing, if you don't have to use integration by long division, then integration by long division can take longer, basically. But yeah, it's not unsatisfying. Next, we've got this one here, which is, if I can remember correctly, this is, I believe, integration by recursion. Yeah, it's satisfying. It's useful, so I'm going to put in A tier. It's not extra satisfying, though, so for that reason, A tier. Next, we've got series expansion. Series expansion is useful in a specific case. It's kind of satisfying as well, so we'll put it in A tier. Next, we've got ln of sine x. I believe you use the Chebyshev binomial, is it? Or is it the... This one's the Lobachevsky technique, which, to be honest, I haven't ever used. It just looks really long and annoying, so I'm going to put it in C tier. I have never used it personally myself, though, so maybe I'm wrong about that. Next, we've got the reverse quotient rule. This is very satisfying, however, it's not got many uses. You very rarely see this in the wild, but when you do, use the reverse quotient rule because it's very satisfying. It just one step, boom, makes it really simple. Next, we've got, this is supposed to be, yeah, there's 2dx's, it's not supposed to be 2dx's. This is, I believe, the caveman technique. You take out x to the fourth from the denominator, and then you can move it to the numerator by multiplying both sides by x to the -4, and then you essentially get an f prime of f of x over f prime of x. So this, very satisfying, useful, yeah, useful. I'm going to put in A tier. Next, we've got, this is converting it into a polar equation. This, I've only ever seen it used for the Gaussian integral, where you integrate e to the minus x squared. Yeah, e to the minus x squared. And that is useful for that. It's a very satisfying integral when you do use it. So for that reason, I'm going to put it in B tier. But other than that, there's only one specific use that I've ever seen it used for. Next, we've got the gamma function, which is very useful. And it's also quite satisfying because it's actually just the factorial function as well. So... yeah, put it in S tier. I mean, it's very useful, very satisfying. So what other tier for it? Next, we've got integration by parts. This is one that's hated by many when they first start learning integration. There are many more difficult ways to do things, like, for example, integration by utter madness. Integration by utter madness is kind of an extended version of integration by parts. So integration by parts, it's got to go above integration by utter madness because it's more useful, definitely, but it's not really that much more satisfying, to be honest. Next, we've got integration by just guessing the answer and then differentiating that answer and ending up with the right integral. This is not very easy to do, but once you get to the point where you can do this, it's very satisfying and very useful. Just start guessing the answer, and I can't put it in S tier because it's not applicable to many circumstances. But sometimes you can just guess the answer and get it right by sheer chance. And when you do, it's very satisfying. Next, we've got the Mellin transform. Never used it before, to be honest with you, so I've got to put it in. I'm going to leave it here. Same with this. Same with these three, to be honest. Yeah, I've never actually... I can't remember what these two are used for. So that's my ranking. I guess that's my ranking. Any comments on that? Any thing that I've missed? Make sure to leave it in the comment section. This video is dedicated to Dustin, who recently became a channel member and suggested that I make this video. And for Dustin, I'm making this video. If you want to see an explanation of all of these, remember to like. And yeah, peace off.